Let's have a look at the next question. Figure 5.1 shows a gas contained in a cylinder enclosed by a piston. At first, the length of the cylinder containing the gas is 100 centimeter. The pressure of the gas shown by the pressure gauge is 300 kilopascal. The area of cross-section of the cylinder is 0.12 meter cube. Describe the motion of the molecules of the gas. The molecules of a gas in general have random motion or move in random directions. Move in random directions, which is in fact given a name called Brownian motion. And these molecules have very high speeds and they often collide with each other and also with the walls of the container. Using the idea of momentum, explain how molecules exert a force on the wall of the cylinder. Whenever molecules collide with the wall of a cylinder, they always change direction. And this change in direction results in a change in momentum, P, and a rate of change of momentum P is in fact nothing but force. So this is how we attach force, or we attach the concept of force to the molecules colliding with the walls of the cylinder. Moving on, the piston is moved so that the new length of the cylinder occupied by the gas is 40 centimeter. The temperature is unchanged. Calculate the new pressure. We know that when temperature is maintained a constant, pressure P is inversely proportional to volume, which means pressure into volume is a constant, which means pressure P1 at volume V1 is equal to pressure P2 at volume V2. So going by substitutions, 300 times 100 into 0.12 is equal to the new pressure or the unknown value of pressure P2 times 0.4 times 0.12. In fact, since we've converted centimeters to meter here, we'll also try to convert centimeters to meters here. You can get 1 meter. So moving ahead, we get the new value of P2 to be 750 kilopascal, which means as volume decreases, pressure will increase. Explain in terms of behavior of molecules why the pressure has changed. We understand that while the molecule or the gas is compressed, the molecules are brought much closer to each other while increasing the kinetic energy. Increase in the kinetic energy of the molecules. An increase in the kinetic energy of molecules results in greater amount of collisions. And these greater amount of collisions in turn, not only with the or amongst the molecules themselves, but also with the walls of the container, in turn increase the pressure.